Ladies and gentlemen, we are going to talk about Chapter 2, and we're going to talk about naming molecules, also known as nomenclature. All right, we want to focus, right? I'm having a little trouble focusing right now. Little distractions going on. Chapter 2, nomenclature. We have to know the name of the first 20 hydrocarbons. That's molecules that have just hydrogen and carbon and no pi bonds. So we're talking about saturated molecules. Saturated, in this sense, is different than the saturated when you were learning about solutions, right? So let's pick out the parts of the two words that are in common, because when you did a saturated solution, what was your definition? It's totally unrelated to saturated hydrocarbon, but there's some relationship between the two words. What does saturated solution mean? The words I want you to use are solvent, solute. A saturated solution has as much solute dissolved as possible. Okay, the only part they have in common, the two saturated, is the as much as possible. Okay, saturated means as much as possible. When it was solution, we're talking about solubility, right? We're talking nomenclature, it's as many hydrogens as possible. So there are no pi bonds in a saturated hydrocarbon. It's all sigma bonds, and there's as many hydrogens in the formula as possible. So a saturated acyclic hydrocarbon. And what's the word acyclic mean? A is the prefix meaning without. And yeah, cycles are rings. So if you know you have a saturated acyclic hydrocarbon, then you also know the formula. CnH2n plus 2. Let me explain the plus 2. If you have a big long chain of carbons, and that's it, then the two ends have only one bond from carbon to carbon each, correct? So there's 3 H's. But every carbon in the middle is between 2 carbons, so there's only 2 H's. There's your 2 N. So every carbon in this thing, from beginning to end, has at least 2 times the number of hydrogens. And then the end carbons each get an extra 1. So there's your plus 2. You get 2N. Okay? So we have a molecule like CH4, and you have to know its name is methane. It was very British of the gentleman who said methane, which is okay with me. When I was in graduate school, we had about 4 British postdocs in our lab. We called them blokes, of course. The blokes would take us out for beers and make us watch soccer games. Okay. They were cool. Methane. And then the next one. What's that called? Yeah, ethane. And what's the next one? Yeah, it's time for stick figures, isn't it? Yeah, we don't want to have to draw all the C's and H's anymore, so we're just going to go straight to, right? Isn't that propane on the left? How about this one? What's that one called? Butane. So those are 4 that make no sense. Yeah, that's the memorizing. There's only 5 you really have to memorize. 4 of them are here. This to me is not memorizing. When I see something that starts with the letters P-E-N-T, in organic chemistry, 5 is the number. Like the Pentagon is a 5-sided building, right? And hey, let's work out the formula of pentane while we're here. C5H 2 times 5 plus 2. What's that? C5H 12. Does it work? We have 3 on the end. 2 more is 5, 7, 9. What? C5H12? What? 1, 2, 3, 4, 5. 3, 5, 7, 9, 12. I was doubting myself for some reason. I don't know. It's 12. Okay. You're going to learn 6, 7, 8, 9, 10, 11. I'll take you up to 10. Are you surprised 10 is called decane? No. 11 is just as easy. You just say 1 plus 10 in the name. And the 2 letters that mean 1 are un. So we're skipping. You got to know them. Doesn't mean don't have to know them. We have decane, which was 10, right? C10, H22. And it's this one, 2, 4, 6, 8, 10. And undecane, 2, 4, 6, 8, 10, 11. And then dodecane, tridecane, they're all on one page in the chapter 2, right? I think it's page 2. Page 2, chapter 2. Dodecane, tridecane, tetradecane, pentadecane, hexadecane. What's the 7 one? Hepta, right? Heptane. What's the 8? Octa. So it would be octadecane for 18 and just octane for 8, right? Octane is 8. Octadecane is 18. And the last one is another memorizer, the 20. Icosane. Because that's not a prefix that you guys commonly use. Unless you're in Dungeons and Dragons or something. Yeah. I believe they use an icosahedral dice in that game. It's a 20-sided dice. Wow. That's pretty cool. Icosane. So that's the parent. That's the foundation of all nomenclature for organic chemistry. When you learn nomenclature, you don't learn it for this test. We're just going to use everything we learned about nomenclature on this test, on the next test as well, and just add a little bit at a time. So all the little rules we start with, and then we just add a new one every time we have a new functional group, or 2 rules. So let's get a preview of how that's going to go. I'm going to put a structure down and name it, and then you see what's going on. It's all related to the first 20. So we're going to name this molecule. Name this molecule. So question 1 is, what is the longest chain? If you start here, you're not going to get the longest chain. You can do better than that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a decane. Did I miss one? Oh, she was giving me the full name. Oh, little experience there, huh? Good. Now, the other choice, there's always 2 ways to do a chain, everybody. But one way is generally better than the other. This name is the right name. And watch what happens to that group here. Not with a number. Here's a symbol that I'm going to use a lot in this course. I bet half of us don't know what it means. I need the other half to help us out. This symbol, if there's a carbon in the molecule that didn't get numbered in the chain, then it's called a group. Therefore, it's not with a number, therefore it is a group. Yes, those 3 dots stand for therefore. I like them a lot. I started my college career as a math student, so we were using therefores and things like that a lot. And that's the therefore symbols from, I stole that from math. So it's called, no big surprise, it starts like methane because it's a 1 carbon group, but you change ane to ill to indicate it's a group. How many groups did we just learn instantly? 20. Okay, if I had a 5 carbon group, what would you call it? Don't call it pentane, it's a group. Pentyl. Groups end with ill. YL. When you see YL, you know, hey, that's not one of the carbons in the chain. So 3-methyl decane. Whoops. My L ran into my D. There we go. Not 8-methyl decane, because there's a rule that says you have 2 names and you're deciding which one's better. The one that has the lower number for the first group is the better way to number the chain. Here we only have 1 group because we're starting simple. So in this case, only look at the methyl because it's the only group. The direction that puts it on a lower number wins. In this case, the red numbers beat the green numbers. So that is the correct name. All right, we got that. Let's do some more. Let's just build a little bit at a time. You ready? I got a question. Yeah.
So with what you just said about the small number, if the methyl part was over at the red 8, it would still be called 3-methyl?
Yeah, because then, yeah, he was asking if the methyl was over here, which is the same molecule, because it's third from the end, and the green numbers would be the right numbers. If the methyl was here instead, it would still be the same name, and it would still be 3-methyl decane, but that would be a 3. All right. So let's do another one. Yeah. Carefully scribble that down if you can. I'm not going to collect it anyway, so you can just watch if you want. So I'm only going to put the correct numbering down. I'm not going to put the other direction. So I'll give you 4 choices for carbon number 1. You want to hear your 4 choices? Top left, top right, bottom right. Where's carbon number 1? Here's top left, here's bottom left, here's top right, here's bottom right. Which one is the only appropriate number 1? Top left does not give you the longest chain, it's right out. Top right does not give you the longest chain, it's right out. You can get a bigger chain if you start with another carbon. Bottom right gives you the longest chain if you go all the way to here. And I hope it's not more than 20. Please tell me it's not more than 20. I will accidentally go beyond 20 and you guys will make me fix it. But yeah, bottom right puts a group on carbon 2. Okay, and gives the longest chain. We have a question. Yes, there's always two ways to number the longest chain. Fact.
No, what I'm saying is that chain has 15 carbons and the other chain has 15 carbons as well. So how do you choose?
Which other chain? This one?
Yes.
Well, that's the same chain. You want to redo this question. Why did I choose, why did I choose red over green? That's what you're asking.
No. There are two chains.
There's one chain that's the longest chain. It's this chain here. If I can write it on my screen, it starts here. It doesn't get to 15 either. 18. That's the longest chain, whether you number it that way or the opposite direction. There are no longer chains. There's many shorter chains. Yes, sir.
On the previous question, I am curious why you chose the red over the green.
Because of this rule right here. He asked, why did I choose red over green? The rule is you choose the direction that puts the group, the first group, on the lowest possible number. So green put it on 8. Green is wrong. Red put it on 3. Red is right. In this one, I only drew the red. The green would have this as number 1, 2, 3, 4, 5, 6, the first group on 6. So following that, I will put those numbers down in green if I can ever select green on my computer. I'm about to call this day. 1, 2, 3, 4, 5, 6. The green system puts the first group on number 6. The red system puts the first group on number 2. Which one's better? The 2 is better. Pick the red. Green is now irrelevant. I'm going to erase it lest I use it by mistake. I don't use the word lest anymore. And that's there. Okay. Now you have to decide where the groups are and what their names are. I'm going to highlight the carbons in the groups. If my computer lets highlight it. This whole thing is a group. It starts there. I didn't highlight the bond because the bond goes to 7, which is not a part of the group, the chain. And ladies and gentlemen, when you're learning nomenclature, have this as your motivation. From the name, you should be able to tell me the number of carbons. From the name, decane has 10, methyl has 1. This molecule has 11 carbons. Since we're on it, it's C11H24. How did I do that? 2 times 11 plus 2. There's no pi bonds there. There's no rings there. Every saturated acyclic molecule has that formula. So if you are naming a molecule and you count a carbon both in the chain and as part of a group, you've made a very bad mistake. That's why I didn't go like this, saying this is my group. I didn't go like that. The group starts there. Right there's the first carbon of the group. Do you agree? 3 carbons in the group. What's the name of a 3-carbon group? Propyl, yeah. There's another group right here. Just this carbon. What's that called? Yeah, methyl. Whoa. Move this here. How are we doing on time? We got good time. And there's another group over here. Ethyl, yeah. And that's it. Everything else has numbers on it already, right? Well, I skipped some numbers, but they're there. Okay, good. Now the question is, our new rule of the day, that's our additional new rule, how do you list these groups in the front of the name. Alphabetically. E before M before P. So ethyl's listed first. Leave space. Methyl's next. Leave space. Propyl's next. Don't leave any more space because the chain name is now. How do you say 18 carbon chain? Octadecane, right? Oh, in red. I'm dying here. That's me trying to move the thing. And octadecane should be in red. Tell me what carbon number is the ethyl attached to? 13. You put that right there with a dash after it. What carbon has the methyl on it? So 2. What carbon has the propyl attached to it? Okay, and that's it. So one little new detail at a time, right? And we can figure out the formula. Let's do it. I mean, it's not a very common exercise, but how many carbons in an ethyl group? How many carbons in a methyl group? How many carbons in a propyl group? How many carbons in octadecane? Add them all up, 21, 22, 24, right? C24, H30. Yeah, that sure beats drawing all the H's and counting them, doesn't it? (24 times 2 is 28, plus 2 is 30. Remember that the only formula you ever memorize is Cn, H2n, plus 2. 48. Yeah, that's why we have these puzzled looks. Dr. Whitaker's magic math happened again. And we rewrote the rules of 2 times 24. Being 28 instead of 48, and that goes to 50, right? Wow, sorry about that. Actually, I think when I make mistakes and you guys catch them, that's one of the best things that can happen on videos. Trust me, I'm not making the mistakes on purpose for that to happen. It's never like that. But when it does happen and we catch it in time, you guys doing your due diligence makes better videos for everybody. Next one, I think our last one of the day.
So would that one be called tetradecane?
No, don't do that. There's no short form for that name. That is a molecule that's never seen the light of day until now, and that's its only name. Okay. And let's do this guy right here. I'm going to introduce a new group, but it's not a killer. It's a halogen. Oh. And I'll put the old stuff on there too. One there, and that's not bad. That's a good finish. 1, 2, 3, 4, 1, 2. I'm going to add 1 carbon to the left to make it an even better example. That's it. Good. Now the chains both, it puts a group on carbon 4 either way. Do you see that? I know you're copying, so you haven't seen it yet. But either direction has a group on carbon number 4. Do you agree? So let's do the full numbering, red and green again. That was supposed to be red. Oops. Learn how to count, please. Did I do that right? I did to 11. The 13 was right. The 11. Oh, wow. That's how you, man. Racing my molecule now. Making red, green, black, blue. 11 followed by 12 followed by 13. So somebody got their wish. We got a pentadecane. But the other direction, I'll do the highlights. 1, 4, 5, 6, 7, 8, 10, 11, 12, get you to 15. Here's how you decide the correct. Can't write on the left of the screen either. Here's how you decide. List only the numbers where there's groups in red and then in green. So the first group in red, give me the lowest number. 4. Next group in red, what's the lowest number? 5. And a 6. And an 8. Watch how I do the one on 9, because there's a group on 9 and another group on 9. See how I did that? There are 2 groups on 9. Those are 2 methyls. And there's a group on 12, and that's the end of the groups, right? And then in green, 4. 7. I don't like green anymore. Don't like it. How come? It's not about the first group. If there's a tie, what's it about next? Second group. And if there's still a tie, you go to third group until you break the tie. Didn't we have 2 groups on 7 and I missed that? Yeah, I did. There's a group on 7, and then the next group was on 7. And then 8. And then 10. And then 11. Then 12. And there's a tie. But the tie gets broken there, doesn't it? Tie gets broken right there. 7 is higher than 5. 5 is superior. Red wins. Red wins. What are those numbers? Before you're looking at these notes, say, he just wrote down a whole bunch of numbers. I have no idea what he did. Those are numbers where there are groups, right? Doesn't matter what the group is, it's where it is. And our new group here, there's 4 new groups. F, C, L. When they're attached, B, R, I. Fluoro. Would be nice if they ended it with YL, wouldn't it? But they didn't. Chloro, bromo, my favorite because it sounds so cool. Iodo. And it goes by B for bromo, right? I'm pretty sure that's first. And so bromo's on 5. Red wins. 5 bromo. I'm going way over here. 5 bromo. Let's highlight those other groups now. We got the bromo. What's that one? Yeah, methyl and another methyl and another methyl and another methyl. That's 4 methyls, right? And then what's this one and this one? Yeah, ethyl. Okay. So we got methyl. Now, how am I going to say there's 4 methyls?
4, 6, 9, 9, tetra.
Oh, that's all I wanted to hear there. But I like what you were saying earlier, too. Tetramethyl means 4 methyl groups in the molecule. So we got to learn our prefixes for how many multiples of the group there are. Do you want to do an oral review of 1 through 10 for the prefixes? 1. We'll never use 1. You don't need to say it if there's 1. You just say methyl. If there's 2 ethyls, though. Di, tri, tetra, penta, hexa, hepta, octa, nona, deca. So when you have, say you had 10 chlorines, you'd say decachloro, right? So each methyl Get this right the first time and you'll never make the same mistake over and over again. Each methyl in tetramethyl, there's 4. Each one gets a number. If you write 3 numbers in front of tetramethyl, quarter point thrown away by you. Some of you want to write just 3 numbers because they see methyls on 4 and they see them on 7 and 6. 4, 6, and 7. And they go, oh, sorry, red, right? 4, 6, and 9, red. Having the greens there messed my brain up. Terrible. So they're going to give me those 3 numbers. How do I know where there's 2? No freaking idea. If there's tetra as a prefix, you better give me 4 numbers. So, like she said, first one was on 4, correct? Second one, what number was it on? Third one, what number was it on? Fourth one, what number was it on? 9, there. Okay? If they're on the same carbon, it doesn't matter. They don't say that methyl is any different than any other methyl in the molecule. It's not. And then I put them in the wrong spot, didn't I? Why is that in the wrong spot? Talk to me. Ethyl starts with E. Yeah. This alphabetizing. If you're in the phone book and there's, 4 guys named Mo, right? You're not in the phone book under 4, are you? You're in the phone book under Mo, right? So this is in the phone book under M. And this is in the phone book under B. And ethyl is under E. Yes.
We do not take the suffixes of prefixes of into consideration. Like
Not. I can't say that. I can't say an affirmative to that question. No. There's some suffixes that do get alphabetized. Read about it on the weekend. You may answer your own question, but we're definitely going to answer it regardless on Monday. Okay. And those ethyls, where are they? Is it 8 and 12? 8, 12, and how do you say there's 2 of them? Di. And then acyl. And that's it. And we're not going to do the number of carbons. When there's atoms other than carbon and hydrogen, don't try to look for a shortcut for the formula. Not this test. Okay? And that's it for today. Good intro. There's more. And you're going to do rings and things too.